So we're talking about mechanisms, and I really want to go over some of the very basics, because just knowing the basics, it can help us working out any mechanism or understanding, interpreting the reactivity of different functional groups just by knowing the basics. So the first thing is that, of course, in organic chemistry reactions, we have bond breaking and bond making. Okay, so these always are shown as curly arrows. Okay, so the curly arrows is the movement of a pair of electrons, and those electrons will move to break a bond, or of course to form a bond. Okay, the homolytic fission is when it breaks evenly, and it's to form radicals, and this is just one mechanism that you'll come across at the radical substitution. So useful to know, but the most important one is the heterolytic fission, really, because most of the most of the mechanism will involve this heterolytic fission. So as you can see from the diagram, it's an uneven breaking of a covalent bond. It forms ions. So one thing to notice is that we have charges, that form as a consequence of this breaking. And this is because maybe we can draw out to understand, because it's so important to understand where this plus and minus come from, because this will help us identifying intermediates in the mechanism. So each bond, it has a pair of electrons, right? In this case, why is it doing? Okay, so I wanted to do this. Okay, so let's say carbon has the dots and chlorine has the crosses. Okay, as both electrons move on to the chlorine has its 7 electrons like before, and it just has one extra, the one that before belonged to the carbon. Okay, which means that carbon now is left with just 1 electron less, and chlorine has just 1 electron more compared to before. That's why we have 1 plus and 1 minus. Okay, we won't see 2 plus or 2 minus. Okay, we will see always plus and minus as a consequence of this heterolytic fission. Okay, so one little thing that I think it's useful to notice, and we will see for the mechanism of alkenes, this is already something to keep in mind. The second most important thing that I want you to focus on is understanding of nucleophile and electrophile, their definitions and some examples, because that's the first analysis that we need to do in mechanism. Nucleophile, it's an electron pair donor. So the curly arrow always starts from the nucleophile, and it moves to an electrophile, which is an electron pair acceptor. So what can donate electrons? A negative ion, something that has a lone pair like the ammonia or any amine. So it has a lone pair of electrons, so it can donate those, or something that it's electron rich, like a double bond. Another that we'll come across later on, it's a benzene ring that has 3 double bonds, so 3 pi electrons. So anything that is electron rich. While electrophile is an electron pair acceptor. So positive ions, something that has positive dipole, in this case would be the carbon, and the oxygen is the negative one, or something that simply has is electron deficient, so it can accept extra electrons. Okay, so one of the first thing when we analyze mechanism is identifying nucleophile and electrophile. We can do it by analyzing the molecules we have and writing down dipoles, because that tells us the direction of the mechanism. So this is really, really, really important, and we will see in some examples. And just to brush off a bit the type of mechanism that we will come across, it's a bit like math, addition, elimination, substitution. Really important is it to understand which type of mechanism by looking at what do you have before, so the reactants, and what do you have after as a product. Okay, that's really, really important, because this will tell us the type of mechanism, if it's elimination, addition, substitution, and then we will have to define this mechanism as a nucleophilic or electrophilic, depending on what you've reacted the reactant with. Okay, we will see how to name it as we do the first example. But looking at the first one, we notice that we start with 1 reactant and we end up with 2 products. So something has been removed from the whole molecule. In this case, is the water. Therefore, would be elimination. So we remove a small molecule from a larger one. Second one, we can clearly observe that this X has been substituted by the Y, so Y has taken its place. So it must be a substitution. So it's important to do this type of analysis, to understand the type of mechanism. The reverse of this, where, for example, water is added into the double bond to form just one product, it would be addition. When we have, for example, this is an ester reacting with water to form two different molecules, this is hydrolysis, yeah? Hydro, water, lysis, breaking down. And then we have some other type, oxidation and reduction. Oxidation and reduction, we've recently seen it in terms of electrons. But in organic chemistry, the other definition of oxidation and reduction, so the one that involves oxygen and hydrogen, it's a lot more useful because it's a bit easier to observe this reaction. So oxidation, gain of oxygen or loss of hydrogen, and it's written as reacting with an oxidizing agent. So this is oxidation. Reduction, it's the opposite, loss of oxygen or gain of hydrogen, as we can see here, loss of a double bond, and we've added hydrogen into that. Okay, so those are the type of mechanism. I don't want you to memorize anything of this. Important thing is to understand how we can observe a reaction taking place. So really looking from the reactants to the products, and then understand, okay, what has happened, what has changed. Okay, so the basics, mechanism type, nucleophile, electrophile, how to identify, and that's the first thing to do when we have a mechanism. And then, of course, understanding the movement of these curly arrows. So those are, I would say, the key parts before looking at each mechanism, which we'll do now.